Okay, let's learn about the law of cosines. You probably already know about the law of sines because usually that's what you learn first, but the law of cosines is a little bit more complicated and a little more involved. So obviously, if you know about law of sines, then you know that it's going to be about triangles that are not right triangles, so they do not have a right angle in them. But if you split a triangle in the right way, you will always have a right angle in that triangle, and that's how you can use the law of cosines, whether or not it's in an easily simple right triangle trigonometry, or you have to use the law. So let's draw a triangle. That's a bad triangle. Let's draw a better triangle. All right. So if we have this triangle, let's say A, B, C, right? Oh, crap. C. So if we have ABC, that means that this side here is little b, this side here is little a, this side here is little c. But if we split this straight down the middle, this is a simple one, then we have a right angle. So let's call one side of the right angle x, and the other side is c minus x. Remember that whole side here is still equal to c. So how do we solve for this? Okay, so if we have one triangle on one side, let's call this height h of the triangle. Triangle 1, triangle 2, right? On triangle 1, x squared plus h squared is equal to b squared. In triangle 2, let's do cosine A is equal to x over b. So these two are true statements because you have those right triangles here, because this side is also a right triangle. This x squared plus h squared is equal to the hypotenuse squared. And then cosine A of this angle right here, that adjacent x is equal to b. Or this is not actually triangle 2, it's step 2 of triangle 1. Sorry if that was confusing. But if we multiply this over, then you have b times cosine A is equal to x, right? So if x is equal to c minus x, or sorry, not equal to, but if we can replace that x with c minus x, then c minus x squared, c minus x whole thing squared, plus h squared is equal to b squared. So if we multiply this out, is equal to a squared, because those are equal. A squared. So we're kind of working with both triangles at the same time here, which is good because they're, actually one triangle. So if we move this on this side, a squared is equal to c squared minus 2xc. We're breaking this c minus x squared out into, we're simplifying it really, plus x squared plus h squared. Well, we know that x from this statement here is equal to b cosine A. And we know that this here, that x plus h squared from this term, is equal to b squared. So we can replace everything. So you end up with a squared is equal to c squared, or let's move it around. Let's go ahead and b squared plus c squared minus 2bc times cosine A. Now you can do this for every side of the triangle. It does not have to be A is equal to B plus, it doesn't have to be in this order. It's just whatever missing side is the same thing. So in this case, A is the same thing as the angle you have on the other side, and then you put the sides that you have in the middle. or you can have that angle and you don't have anything else. So you can plug this in various different ways, is all I'm saying. So you can have this, or you can have b squared is equal to a squared plus c squared minus 2ac times cosine b. Or you can have b squared is equal to a squared plus b squared minus 2ab times cosine c. And these are all different variations of the same law that we can use to plug in into this triangle. So the one with b, this one here, is the one that you'll see most often. Is the one that you'll see most often, like, written out. But again, you don't have to memorize where the variables go as long as you know what pattern they go in. Okay, so let's try a practice problem. Since we're just now learning about this, or if you've already learned about it and you're trying to freshen up, that you're freshening up on it, let's write the formula here. We can get rid of this triangle too. Half of this video is just me erasing. Okay, so let's do a squared is equal to b squared plus c squared minus 2bc times cosine a. And that's our equation. So let's say we solving a triangle. Solve this triangle. Solving a triangle means to find all of the missing sides. So if we draw a triangle here, draw a good triangle here. Let's say A, B, C. I never leave enough room for the C. Let's say A is equal to 11, B is equal to 5, and big C, the angle, is equal to 20 degrees. So that means you have 11 here, you have 5 here, you have 20 degrees here. So what do we have to solve for? We have to solve for C, this C here. We have to solve for measure of angle A and the measure of angle B. So I'm going ahead and leaving spots for those here so you don't have to deal with it later. So if we plug it into one of the law of cosines equations, let's say c squared, that missing value, is equal to 11 squared, the value we have, plus 5 squared, another value we have, times 2 times 11 times 5 times cosine, that missing angle, or that missing side, is 20 degrees. You can go ahead and solve this out by yourself if you want to. Go ahead and pause at any time and work ahead. So c squared, when you plug it into the calculator, is 42.63 rounded. So if you square that, then you end up with 6.53. So c is equal to 6.53 units. Let's just say this is in meters. Or we didn't get any units, so we can put UN. And now we need to solve for the measure of angle A and the measure of angle B. So if we plug it into another equation, let's say 11 squared, because that's the angle we have for A, or the side we have for A, is equal to 5 squared plus that side we just solved for, that 6.53 squared, minus 2 times 5 times 6.53, running out of space, times cosine. We don't have that angle, so that would just be times cosine A. If you solve this out, cosine A is equal to negative 0.82. And then if you do the inverse cosine of that, then you get 144.8. So obviously our triangle is not to scale, but A is equal to 144.8 degrees. Now, if you want more practice, you can go ahead and plug it in again and find the measure of angle B. But we know that all three measures of the triangle are equal to 180. So if you have 180 minus 20 minus 144.8 degrees that we just solved for, then you get 15.2 degrees. So the measure of angle B is 15.2 degrees. And this problem was pretty involved, so we're just going to leave it at that. But again, as extra practice, you can solve out for the measure of angle B using the law, and the more you practice this, the easier it is to memorize it. But that's all you need to know for law of cosines.